Hey everybody, Tony here. I bet you didn't know how confusing machine learning buzzwords can be. We're talking algorithms, data, and enough technical jargon to make your head spin. But don't worry, we're breaking down the top 39 buzzwords you need to know. Whether you're a tech newbie or just need a refresher, this video is your one-stop shop for all things machine learning. Get ready to impress your friends with your newfound knowledge. Or at least sound smart at parties. Let's do this thing. First up, the big kahuna, the head honcho, the top dog. Artificial intelligence, or AI for short. You know, like robots taking over the world? Not quite, but kinda. AI is basically the science of making machines smart. We're talking computers that can learn, reason, and solve problems like us humans. Sometimes even better. Now, here's where it gets a little tricky. People often use AI and machine learning interchangeably, but they're not exactly the same. Think of it like this. AI is the overall concept of smart machines, and machine learning is one way we achieve that. It's like AI is the pizza, and machine learning is the cheese. Delicious, but not the whole pie. So, next time you hear AI, remember, it's all about making machines think, and machine learning is just one tool in the toolbox, albeit a very important one. Alright, buckle up, because we're going deeper. Literally. Deep learning is a type of machine learning that's all about, well, going deep. Think of it like this. Remember those stackable potato chips you loved as a kid? Deep learning is like building a massive tower of those chips, except instead of potatoes, it's layers upon layers of algorithms called neural networks. Each layer processes information and passes it on to the next, getting smarter and more complex as it goes. This allows deep learning models to tackle really complex tasks, like image recognition, natural language processing, even writing cheesy voiceover scripts. It's like the difference between teaching a dog a simple trick and teaching it to play chess. Deep learning is powerful stuff, and it's behind some of the most impressive AI breakthroughs we've seen. So, next time you're amazed by a computer doing something incredible, chances are deep learning is involved. Pretty wild, right? I hope you're liking the video so far. Please hit like and subscribe, it really helps out the channel. Stay curious and please keep watching. Okay, so now we're diving into the world of machine learning algorithms, starting with supervised learning. Imagine you're teaching a dog a new trick, like shaking paws. You show the dog what to do, give it a treat when it gets it right, and correct it when it messes up. That's kind of what supervised learning is like. We give the algorithm a bunch of labeled data, which means the data is already tagged with the right answers. Think of it like giving the algorithm a cheat sheet with all the answers highlighted. For example, if we're teaching an algorithm to recognize cats and dogs in pictures, we'd show it a bunch of pictures labeled cat or dog. The algorithm learns from that labeled data and tries to figure out the patterns that distinguish a cat from a dog. And the more labeled data we feed it, the better it gets at recognizing those furry little creatures. It's like showing a kid a bunch of flashcards with letters on them. Eventually they start to recognize the letters and can read words. Supervised learning is all about pattern recognition and making predictions based on labeled examples. Let's say you're trying to sort out a giant pile of laundry, but you've never done laundry before. There are no labels telling you what's what. You probably start grouping things together based on their similarities, right? Like putting all the socks in one pile and all the shirts in another. That's kind of what unsupervised learning is like. Instead of having labeled data with all the answers, the algorithm has to figure things out on its own. It's like being thrown into the deep end of the pool without floaties. The algorithm looks for patterns and relationships in the data without any guidance. It's like playing a game of connect the dots, but you have to figure out the picture yourself. Unsupervised learning is great for things like clustering, which is grouping similar items together, like customers with similar buying habits. It's also used for anomaly detection, which is finding those weird, out-of-place data points that could be important, like fraudulent transactions. The program learns which actions lead to the best outcomes and becomes an expert in whatever task. Alright, picture this. You're standing at the base of a mountain. But this isn't just any mountain, this is Mount Data, and it's made entirely of, you guessed it, data. I'm talking emails, tweets, YouTube comments, cat videos, the works. We're talking about a truly massive amount of information, like way more than you could ever hope to sift through on your own. I mean, have you ever tried reading through the entire internet? Yeah, not fun. But here's the thing, buried within this colossal mountain of data are hidden gems, valuable insights waiting to be unearthed. And that's where machine learning comes in. You see, machine learning algorithms are like those treasure hunters, those digital Indiana Joneses, who can sift through all that data and find the good stuff. They can identify patterns, make predictions, and help us understand the world around us in ways we never could before. So yeah, big data can be overwhelming, but with the power of machine learning, it's also an incredible opportunity. It's like they say, one person's trash is another person's treasure. Okay? So you've got your Mount Data, this massive pile of information just begging to be explored. But you can't just grab a shovel and start digging, right? You need the right tools, the right techniques. That's where data mining comes in. Think of data mining like, I don't know, panning for gold. You've got your pan, which is like your algorithm, and you're sifting through a river of data, looking for those precious nuggets of insight. Except in this case, the gold could be anything. Customer trends, hidden patterns, maybe even the secret to making the perfect viral video. Okay, maybe not that last one, but a guy can dream. Data mining algorithms are designed to dig deep, to analyze massive data sets, and uncover hidden relationships that we might not even know to look for. It's like having a sixth sense, a way of seeing patterns and connections that would normally be invisible to the naked eye. And the best part? The insights we gain from data mining can be used to make better decisions, improve our products, and even solve some of the world's most pressing problems. So yeah, data mining is pretty much the coolest thing since sliced bread, or maybe even cooler than that. It learns and makes predictions. Most accurate predictions. Simple, not too complex, but just right. Be brutal. All right, time to put on our imaginary hard hats and enter the world of model training. This is where the magic happens, where we take our raw data and mold it into a powerful prediction machine. Imagine it like this. You're a sculptor, and your data is a giant block of marble. During training, we're chiseling away at that marble, refining our model, making it better and better at understanding the patterns hidden within the data. It's like teaching a kid to ride a bike. Lots of wobbly starts, a few scrapes and bruises, but eventually they get the hang of it. We feed our model tons of data, showing it examples and telling it, this is a cat or this is a dog. And with each example, the model adjusts its internal settings, getting closer and closer to understanding what makes a cat, and a dog, a dog. It's a process of trial and error, like finding the perfect temperature for your morning shower. Too hot, and you burn yourself, the model overfits. Too cold, and you freeze, the model underfits. We're looking for that sweet spot, that perfect balance where our model can generalize and make accurate predictions on new, unseen data. Chapters. It's Michelin star good. You know the kid in school who aced all the tests, but then completely froze during the final exam? Yeah, that's kind of what overfitting is like in machine learning. Your model might seem like a genius when it's tested on the same data it learned from, but in the real world, it crumbles, like a stale cookie. That's where cross-validation swoops in to save the day. It's like a training montage for your model, but instead of running upstairs and dodging punches, it's all about learning to generalize and not be a one-trick pony. Here's how it works. Imagine slicing your data into, let's say, 5 equal parts, like a cake. You train your model on 4 slices and then test it on the remaining slice. Then you do it again, but you switch up which slice is held out for testing. You repeat this process until every slice has had a turn, being the test slice. This way, your model gets tested on different parts of the data and learns to adapt to variations. It's like giving your model a taste of the whole buffet instead of just letting it gorge on breadsticks. The result? A more robust and reliable model that's ready to tackle the real world, one delicious bite at a time. Alright, so you've got your machine learning model, right? You've trained it on a ton of data, like a ridiculous amount, and it's spitting out predictions left and right. But here's the thing, you have no idea how it's doing it. It's like, hey model, how'd you know that was a picture of a cat wearing a tiny hat? And the model is all like, dude, I don't know, I just do. That's a black box model. It's making decisions, but the inner workings, the logic, the why behind it all, is a mystery. even to the people who built it. It's like trying to figure out how David Blaine does his magic tricks. You know something crazy is happening, but the actual process is completely hidden. Now, this might not seem like a huge deal at first. If it works, right? But imagine using a black box model for something super important, like medical diagnoses or self-driving cars. You kind of want to know how it's making those life or death decisions, wouldn't you? That's why black box models can be a bit of a problem. They're powerful, sure, but they lack transparency. And when you're dealing with important stuff, transparency is key. It's like that saying, trust, but verify. Except, with black box models, you can't really verify. You just have to trust that the magic is working. Spooky, right? How cool is that? Alright, let's talk about language, the thing that separates us from the chimps. Well, one of the things anyway. We humans, we love to talk, to write, to communicate in all sorts of weird and wonderful ways. And for a long time, computers were like that friend who just stares blankly when you try to tell them a story. They just didn't get it. But then came natural language processing, or NLP for short, and suddenly, computers started to understand us. NLP is all about teaching machines to understand and process human language. Whether it's written text or spoken words, it's like giving computers a crash course in all things language, from grammar and syntax to the subtle nuances of sarcasm and humor. Think about all the ways we use language every day. Texting, emailing, searching the web, talking to our voice assistants. NLP is the magic behind all of that. It's what allows you to ask Siri for directions, translate a website from Spanish to English, or have your emails automatically sorted into different folders. And the best part, NLP is constantly evolving and getting better. We're talking about machines that can write poems, compose music, and even hold conversations that are almost indistinguishable from those of a real person. It's both amazing and a little bit terrifying, kind of like that time I accidentally ate a whole ghost pepper. But hey, that's the beauty of technology, right? Always pushing the boundaries and keeping us on our toes. Or at least your skin. Time series analysis. Sounds boring, right? Wrong. It's like Back to the Future, but with data instead of DeLoreans. Basically, it's all about analyzing data that's collected over time. Think stock prices, weather patterns, or even how many times I say dude in a Smush video. By looking at past trends, we can try to predict what's going to happen in the future. Like, will the stock market crash? Will it rain tacos tomorrow? Okay, maybe not the tacos, but you get the idea. It's about spotting patterns and making educated guesses about the future. A unicycle on a tightrope moment. Wear a raincoat. Just saying. Analytics might have a clue. Alright, let's talk AutoML. That's short for automated machine learning, which basically means machines are learning to do machine learning. Is your mind blown yet? Because mine is doing backflips right now. Remember how we talked about algorithms being like hungry little data monsters? Well, AutoML is like giving those monsters a buffet and a personal chef. It automates all the boring, repetitive tasks in machine learning, like selecting the right algorithm, tuning all those pesky hyperparameters, and even deploying the model. Think of it like this. Machine learning is like baking a cake from scratch. You gotta measure all the ingredients, mix everything together, bake it at the right temperature, and hope it doesn't come out looking like a pancake. But AutoML? AutoML is like using a cake mix. You just add water, mix, and bake. It's machine learning made easy. Now, if only there was an AutoML for cleaning my apartment. Please click subscribe and like the video, as it really helps the channel. Thank you for watching. Stay curious, keep watching, and enjoy the rest of the video. Hey guys, welcome back to Top Machine Learning Buzzwords Explained. Simply, we're getting close to the end of this wild ride, but buckle up. because this next one is all about living on the edge. No, not emotionally, like when your crush says they only like you as a friend. We're talking about Edge AI. So, imagine you have a smart device, like your phone or maybe even your refrigerator, that's using AI to do cool stuff. Usually, all that data your device collects gets sent to the cloud, processed, and then sent back. That's a lot of back and forth, right? Like, are you lost or something? Well, Edge AI is like, nah fam, we're bringing the processing power to the device. That's right. With Edge AI, the AI magic happens directly on the device. This means faster processing, more privacy, because your data isn't traveling as much, and it's more reliable even when the internet connection is, let's just say, questionable. Think about self-driving cars. They need to make split-second decisions, and they can't be like, hold on, gotta upload this video of a pigeon crossing the road to the cloud first. Edge AI makes those real-time reactions possible. So, next time you hear someone talking about Edge AI, just imagine a little AI brain living inside your phone, making decisions and doing calculations at lightning speed. It's pretty awesome when you think about it, and hey, it's way less dramatic than living on the edge emotionally. Trust me, I know a thing or two about that. Protecting your nose. Maybe one day, they'll be teaching us a thing or two. Alright, Gans. These things are wild, dude. Imagine two neural networks, right? One's like a master forger trying to make fake Picassos, and the other's the art critic trying to tell if it's real or totally bogus. They're locked in this epic battle, constantly trying to outsmart each other. The forger gets better at making fakes, the critic gets better at spotting them, and on it goes. Eventually, the forger becomes so good, it's creating masterpieces even experts can't tell are fake. That's GANs in a nutshell. They can generate super realistic images, music, even text, and they're revolutionizing everything, from video games to fashion design. I mean, just imagine the possibilities. Imagine a world where you can generate your own custom video games or design your own clothes without ever having to sew a stitch. That's the power of GANs, baby. They're constantly learning, evolving, becoming even more powerful. It's kind of scary, but also super cool. Pretty mind-blowing, right? Classifying anything. Spam emails, medical images, you name it. SVM can draw the line. Information in a sea of data. Alright gamers, this one's for you. Q learning. It's all about learning by doing, just like leveling up your character in a video game. Imagine you're playing a game, and you have a bunch of choices to make at each level. Q learning is like your character figuring out the best action to take in each situation to get the highest score, or, in machine learning terms, the biggest reward. It's all about trial and error, trying different things, and learning from the consequences. So, let's say you choose a path, and you get a power-up. Awesome! That's a positive reward. But if you choose a path and get attacked by a monster, bummer. That's a negative reward. Over time, the algorithm learns which actions lead to the best rewards and becomes a total pro at the game. Think of it like training an AI to dominate at Mario Kart. And more algorithms. Few-shot learning is still a relatively new area of research, and it's not perfect. But it has the potential to revolutionize the way it gets a surge of electricity. Alright, get ready to have your minds blown, because zero-shot learning is some next level stuff. It's basically teaching a machine learning model to predict things it's never seen before. I know, right? Mind blown. Imagine showing a dog breed identification app a picture of a Tibetan Mastiff. a breed it's never encountered. In zero-shot learning, the app, using its knowledge of dog characteristics like size, fur, and face shape, would be able to correctly identify the Tibetan Mastiff. It's like, the model has this uncanny ability to connect the dots and make sense of new information based on its existing knowledge. It's like that friend who aces every test, even though they never study. Except, instead of cramming for finals, this friend is crunching data. Zero-shot learning has some seriously cool potential applications like image recognition, natural language processing, and even drug discovery. It's like the future of AI is already here, and it's learning faster than ever. High-performing machine it was meant to be. And there you have it, the top most common machine learning buzzwords demystified. We've gone from AI basics to zero-shot learning, covering everything in between. Give yourselves a round of applause for leveling up your AI knowledge. I hope this video has equipped you with the knowledge you need to navigate the ever-evolving world of machine learning. Remember, this field is constantly growing and changing, so keep that curiosity burning. Thanks for watching. If you found this video helpful, don't forget to please like, subscribe, and hit that bell notification to be notified for more in-depth explanations on machine learning and AI topics. Until next time, stay curious,